Hello class, welcome to lecture 2 of the PUAD628 Statistical Applications course. So we're going to talk about describing a single variable. And you may be familiar with the terms that we're going to look at in this particular lecture. And so if you are, that's great. If you're not, no worries. We're going to learn it now. So there are many different ways to summarize statistical variables, both with numerical summary measures and with charts. In order to learn how the values of a variable are distributed, we can ask a number of questions. Okay, recall that this is a statistics class, so the kinds of questions we would ask are as follows. What are the most typical values? Right, and last week we learned what values are. Values are the answers to a question, and the question is the variable, right? So here we're asking, what is the most frequently seen value? What answer was given most frequently in this survey? What we call that is the mode. The mode is the most frequently given answer to a question, a survey question. Okay? How spread out are the values? How spread out are the values? For example, your value may be 30. Another person's value for age may be 53. So we're looking at how spread out that is, right? And that we can measure the spread of values by looking at range, and we'll look at what that means in future slides, and when we can also use standard deviation. The third bullet here asks, what are the extreme values on either end? Extreme values, we look to the left, or to the bottom, however you want to look at it, and that's our minimum value. The maximum value is the highest, right? And then outliers tend to also be either minimum or maximum, but they stand out beyond what the other values are kind of hovering around. Okay? And then the last question is the chart of the values symmetric about some middle value, or is it skewed in some direction? We can say it another way, does it have any other peculiar features besides possible skewness? And we are able to measure that by looking at the mean and by looking at the median, depending on the type of value we're looking at there. So all of these terms are going to be discussed further on in this lecture too. Definitions, yay! So we have two measures that we're looking at in this lecture: measures of central tendency and measures of dispersion. Central tendency helps us to simplify data even further than frequency tables and charts by providing measures of the center. So we can look at the center in terms of the most common value given for that variable. We call that a mode. We can look at it in terms of the median, which is the middle value, the middle observation. We can look at it in terms of the mean, which we know in layman's terms, and we've heard this pretty much all of our lives, right? The average. The mean is another word for the average value of a variable. We can also describe a single variable in terms of its dispersion. It's an indication of how the values are spread out around their center. So the range is one type of measure of dispersion, and essentially it is the highest value minus the lowest value. That is the range, going from top to bottom, left to right, however you want to look at it. That's our range. That's the basic, most simplest form of spread that we can measure in statistics. Okay? We also have standard deviation, a little bit more technical, but we'll learn how to get through it and how to interpret it, how to calculate it and how to interpret it. And it measures the deviation or the spread of the values from the mean. So from the mean of that value, how much are the other values sort of close to it or far away from the mean? We also look at interquartile range, which is how spread out the values are from the middle, which we know another word for the middle, as we can see at the top there, is median. The middle value is the median value. The average value is the mean value. The most frequent value is the mode value. Okay, and so where standard deviation deals with the mean, interquartile range deals with the median. Okay? Let's take a look at the the mode. One form of central tendency measures. The mode, as we said, is the value in a data set with the largest number of cases, the most frequently seen value in that data set, that sample. To find the mode, determine which value has the highest frequency in the table. So here we have 10 observations. We can see that from the first slide. Observation number 1 is A. Observation number 5, someone else got an A. Observation number 9, someone got a B. Observation number 10, that person got a C on the midterm grade. Okay, so this is just a basic data set with 10 observations, or 10 people, or specifically 10 students, right? And this is their midterm grade. So which type of variables can modes be used on? Is it nominal, ordinal, interval? Well, all types of variables. Every type of variable, right, you can see which one, which value is most frequently seen in the data set. But which one is easiest to see? Probably the nominal variables or the ordinal variables, because they're in categories, right? So we can see those much easier. Granted, you can see the mode for all variables though. And then showed you the answer there, but what is the mode of this data set of 10 students? Well, it says here B, so let's count how many A's we have. We should see 1, 2, 3 A's. Let's see how many B's we have. We have 1, 2, 3, 4, and 5. Well, we have 5 B's, which is more than the A's. All right, so that's winning so far. And then C's, we have 1, 2. So that's the least number of values. So our mode here is B, because that's the value that we see most frequently, has the highest number of cases in this data set. Okay? Alright, here's another data set. We've got 1, 2, 3, 4, 5, 6. 6 people in this data set. We've got a director, an assistant director, a clerk, 1, 2, and 3, and we've got a secretary. And we can see their salaries here. What is the mode in this data set? So recall from the question right above it, which types of variables can have modes? Well, in this data set, the type of variable, hopefully you're saying it's an interval level variable, because these are exact numbers, right? And so we can see that this variable, this data set can have a mode. This variable can have a mode. But what is that mode? What is it? Well, they all appear the same number of times. 42,500 appears the same just once, and all of them appear just once. So our answer here is, we can say all of the values are modes, or we honestly could say none of the values are modes, right? However you want to look at it, half full or half empty cup, right? Each salary is listed here once. So let's backtrack just a little bit, because we know that this variable salary is an interval level variable. Hopefully we can look up at the midterm grade variable, and we can see that it's an ordinal level variable, because there is order to it. We know that A's are higher than B's, and B's are higher than C's, and we're rooting for an A. I'm rooting for an A for you, right? For your midterm and your final course grade. So there's order to the midterm grade. There's also order to the salary variable, but it's very specific here, so we can call it an interval level variable. All right. Okay, so central tendency, the second measure that we're going to look at is median. The median is the middle. Just whenever you hear median, think middle, okay? And the value that divides an ordered, important to say that, ordered distribution into equal sized halves, where with the mode, it doesn't matter the type of variable that we have. We can have an ordinal, interval, or nominal level variable. But with a median, it has to be ordered. It has to be an ordered type of variable, whether it's interval or ordinal. There has to be order to that variable in order for us to know what the median is. And I'll show you why here. Okay, so here's our example. Same data set that we saw, same variable from the same data set that we saw in the previous slide. Here we see that the first line now says clerk 1, second line says secretary, and we see the salaries. They're not in any particular order, right? And so if we take the equation that we see here on the top about how to find the median, this is the equation for how to calculate the median. First, you have to put it all in order, the observations, and you put it in order in terms of whatever that order would be for the variable. Okay? So for this variable salary, we can either go from the lowest to the highest, or we can go from the highest to the lowest. Okay? We take the total number of observations, which is 1, 2, 3, 4, 5, 6. So there are 6 salaries here. We take 6. You see number 3 there. The value of n plus 1 over 2. So let's do that. N is the number of observations. So 6 plus 1, which is 7. 7 divided by 2, which is 3.5. Okay, so the 3.5 observation. The 3.5 observation. I know that sounds a little weird, but bear with me, stick with me right here, and we'll get through it. So we just did this equation. We counted all the observations. We see that we have only 6 observations. 1, 2, 3, 4, 5, 6. Counted it again just to be sure. We put 6 into that value for n. So 6 plus 1 is 7, divided by 2, that's 3.5. So, now that we have that value, we want to count down to 3.5. So we would start with clerk and say that's the first observation. Secretary, second observation. Director, third observation. So somewhere in between director and clerk 2, because clerk 2 is the fourth observation. So somewhere between director and clerk 2, we should have our median if we did this correctly, right? So what we do is we take those two values, we add them together, and we divide by 2. And as you can see in red at the very bottom, our median is $32,550. Okay, now is that correct? Well, no, because it's not listed in order. It's not listed in order. So what we need to do is we need to put it in some type of order. So I decided, oh, okay, let's put it in descending order. So the highest salary first, the lowest salary last. We could have put it the opposite way. It would still be in some order. In the left, we can see there is no order to it. 22,600, 17,500, it's going down. Then it goes back up to 42,500. No order about that list. So now that we have put it in order, and we still have from step number 3 our equation 6 plus 1, which is 7, divided by 2, which is 3.5. We still have that, so let's use this right-sided um, table to come up with our mean. So we would count to 3.5. The first line is 1 for director, second line, assistant director, third line, clerk 1, fourth line, clerk 2. So somewhere in between clerk 1 and clerk 2 is our median, and that is $22,550. That's the median salary for this particular data set. Okay? Take a look at it. May have to pause here just so that you make sure you get it before we move forward, okay? But I'm going to move forward, but please feel free to pause, okay? Alright, let's take a look at median again, because we have to do this just because people, this is not new, this is, new for some people, a lot of people, to be frank, and so I feel it's important for us to go through a couple more of this, unlike with the mode when there was no calculation required. Okay, so median, step 1, just like in the previous slide, is to put the cases in order. And it's currently not in order. As we can see, we have AAA, then we have B, then we go back up to A, then we have B, right? And so there's no order there. Not in order. So here, we have put it in order, okay? We should see 1, 2, 3 B's, we should see 1, 2 C's, and that means the rest of them should be A's, which should be 5 A's. 1, 2, 3, 4, and 5. 5 A's. Now it's in order. Smiley face. Okay. So, step 2. Count the number of observations. What is M? M, we don't even have to worry about counting, right? Because it's counted it for us. There are 10 observations. 10 grades that we are looking at right now. Step 3. We simply calculate what observation would be the median observation. So 10 plus 1, that's 11. Divide 11 by 2, that's 5.5, 5.5 observation. The 5.5 observation. Okay, so let's go to 5 at the bottom, and let's go to 6 at the bottom. So somewhere between 5 and 6 is our median midterm grade. Somewhere between an A and a B, so maybe an A minus or a B plus, I don't know. Somewhere between A and B is our median midterm grade. Hopefully that flowed a lot better for you now that we've done it the second time around. Okay, so first step, put the cases in order. Second step, count the number of observations. Third step, simply plug in this equation. Make sure you add first and then add everything in the parentheses, then divide. And that is not your median, that's just where you would find your median, right? 5.5 is not your median. Your median is wherever your 5.5th observation. So it's between 5 and 6 observation. So it's somewhere between A and a B midterm grade. So the use of frequencies, not the number of categories. I just said that. So, use the number of frequencies, not the number of categories. So literally what I just said is that. And I said that too. Yay. Now let's move on. So now let's move on to the mean, the third way of measuring centrality of a variable's values. Okay, this looks like a lot, but trust me, it's not. You've done medians before, means before. You calculated averages before. If you haven't, we're going to go ahead and do that now. The way you calculate an average is you add up every value, right? So for our equation, for the table we see here, we have male, male, female, male, female, female, and we have how much they weigh in pounds. So if we want to get the average weight here, step one says to add up all the values to get the sum. The sum would be 100 plus 200 plus 150 plus 200 plus 250 plus 100. That's the sum. And what the top part of this equation is showing you, that E looking sign, that means sigma. It's a Greek word sign for sigma. And the x to xi, x sub I, sigma x sub I, essentially all that is telling you is that you have calculated the sum of all of the values. As you can see in the box there, it means the sum of all the individual values from x all the x1 all the way to the very last value. That's what that means. Okay? Step 2, divide the sum by the total observations, or the total count. So we already know, we're pros now at what n means. So we take that sum and we divide it by n. N is our total number of observations. So, and we already know that there are only 6 people here, 3 males, 3 females. So we take our sum, divide it by 6, and what we should get is 150. So what is 150? It's the mean weight in pounds, or the average weight that between the 6 people in this sample. Okay, let's do it again. You guys know these 6 people, the director and the clerks and all that, secretary. So what would we do? Again, we would sum up all these numbers. We would divide it by, yet again, the total number of observations is 6. So we would just divide by 6. And that would be our average, or our mean salary between the 6 people. Okay? All right. So, how do we get the mode, the mean, and the median when we have grouped data? Well, first off, let's find the data. So here's data, and we can group this in a certain way, right? We can see that there are 4 90s, 1 100, we've got 3 80s, and we've got 2 70s. Okay? So step 1, count the number of values and record them in order. We've already done that, right? We counted that there's 1 100. We counted that there's 4 90s, 3 80s, and 2 70s. Okay. Now, step 2. We multiply the value by the count for that value. Add them all up. So first, maybe I should have made that add them all up the 3rd step. But here's what we mean here. Multiply the value by the count for that value. So the count is 1. We multiply that by 100. Should be 100, right? We have 90. We can do 90 plus 90 plus 90 plus 90. Or, based on what we learned in elementary school, right? We can just do 90 times 4. So 90 plus 90 plus 90 plus 90 is the exact same thing as 90 times 4. So this slide is simply just allowing us to do things quicker, right? Because we're grown-ups now. We don't have to add everything up. We can multiply when there are multiple things that can be grouped together. All the 90s can be grouped together, all the 80s, all the 70s, and we can multiply them by the total number that there are for those values, okay? So 100 times 1, 90 times 4, 80 times 3, 70 times 2. That's how we get the sum, right? Or we could just do 100 plus 90 plus 90 plus 90 plus 90 plus 80 plus 80 plus 80 plus 70 plus 70. Either way you do it, and feel free to try that right now if you don't believe me. Either way you do it, you're going to get the same sum. You're going to get the same sum. Okay, so that's all step 2. Now step 3, just like we did in the last step 3 in the previous slide, you divide by the total number of observations. What is the total number of observations? It's the same, and it's 10, right? So you take that sum, you divide by 10, and you should get them. I went ahead of myself. So the mode, yes, it should be 90 because that's the one we see most frequently in this variable, right? It's the value that is most frequently seen in this variable. Final grades, okay, 90. There are 4 90s. So our median would be that 10 plus 1, right, which is 11, divided by 2, which is 5.5. So halfway between 90 and 80 should be 85, or halfway between that 5th observation and the 6th observation should be that 5.5. So that's why we're taking the average of that, and we're saying, and we're concluding that our median would be 85, right? 90 plus 80 divided by 2. Okay? And then finally, our mode, what we did already is that 1 times 100, 4 times 90, 3 times 80, and so on. We get our sum, and then we divide it by 10. Okay? And our median might be 85, our mode might be 90, but the average is a little lower at 84%. Is the final grade average. Okay? So those 70s seem to pull it down a bit, but alright, so here's another example of grouped data. You should all be familiar with this type of table because we did this last week or in lecture 1. So unlike the previous slide where we saw group data looked a little different, it's a table I created. Here we see group data set up in the way the statistical software sets it up. Okay? And we can see the values right there all the way to the left. We know the values are representing the variable for how many years of education do you have. So the highest was 10 years of education, meaning they didn't go past the 10th grade, or 20 years of education, which seems like it's a master's degree, I guess. And so that's the highest degree that's listed here for the participants. Okay? And then we can see our frequencies there. So our values, please keep in mind, I promise you people get this confused all the time, so please allow me to stress that values are the most important things here. That is what the answers are, right? The frequency just tells you how many times that answer was provided. So we can see that 12 people said, I only finished 10th grade. I didn't go past 10th grade, right? So how many people said that they are college graduates? Well, 12th grade is a high school graduate, and we add 4 years, possibly 16, right, would be a college graduate. So 290 people in this survey graduated from college. 18 people graduated with a master's degree of some sort. Okay? 330 people graduated high school. Or that's their highest degree. More than 330 people graduated high school because there's 13 and 14 in the value 15 and so on, right? But the highest degree for most people, for those 330 people, was a high school degree. Alright, so our mode is that 12 years of education. high school. What would our median be? Let me give you a sec here. So, how would we calculate our median? Remember the equation, n plus 1, and then you divide that by 2. So what is our total number of observations here? Our total number of observations should be 1,000. 1,000 people were surveyed and provided valid responses. Okay? So 1,000, that's our n, plus 1, okay? That is 1,001 divided by 2. That should give us 500.5. So we now know that our median would be that 500.5th observation. So how did we figure that out? Well, in this frequency table, first off, it's already in order. So we didn't even have to worry about, whoa, should we put it in order? Wait, we can't go to step 2 without putting it in order. Every frequency table that you should ever come across should already be in order. That's the beauty of frequency tables. When you have values, it puts it in the order that it should be, unless something went wrong in the coding. Okay? But generally speaking, a frequency table is a table that provides the values in some type of order for you. Okay? So, step 1 was already taken care of. It was already in order. Step 2, when we did our n plus 1 divided by 2, now we're trying to find 500.5. Or we're trying to find 500 and 501, and then we're gonna look in the middle and figure out what that 500.5 value is. So what I would do in this case is we can see there's 330, and we can see that 101 plus the 12. So we're already at 443. So that 14 would give us technically a whole nother 100 and more. So we would already be over the 500 and 501. So somewhere in between, somewhere in that value 14 for years of education has the 500 observation and the 501 observation. So there's no need to even try to figure out what's in the middle, because they're all the same. 500, 501, even 499 and 502, right? It's all in that observation, the value 14. So our mode would also, our median would also be 14 years of education. Alright, so our mean, our average, how do you suggest we calculate that? Well, aren't you lucky, aren't you glad, because I'm glad, that we just learned how to deal with grouped data. Otherwise, we would have done 10 plus 10 plus 10, 12 times. Then we would have done 12, 330 times. Or we can simply multiply 10 times 12. And then we add 12 and multiply. So, okay, 10 times 12 plus 12 times 330 plus 13 times 101, and so on. Okay, here we have it here, and so on. So you're multiplying, then adding, multiplying, then adding. So your sum should be about 14,366. Step 2 would be to divide it by the total number of observations. We know that it's 1,000, so our mean education is 14.4 years of education. It's about the average of what the people in this sample have. So maybe like an associate's degree or so. Next is dispersion. So we just talked about the 3 ways of calculating the centrality of a variable's values. Now we're going to look at the dispersion, or the spread, or the distribution. Any of those 3 words describe how spread out the variables are, the values are for a particular variable. So range is the basic form of spread, the basic form It's the simplest measure of spread for continuous variables. And essentially, the way you calculate range is you get the highest number, you subtract it by the lowest number, and that number you get is your range. Then we have the interquartile range. This one is based on the median. So the interquartile range is the first quartile minus the third quartile minus the first quartile, and therefore we call it the IQR. It's the middle 50% of the data, interquartile. So the inner 50%, right? Because we know the median is the halfway point of that data, of that variable's values. And so when we take the interquartile range, we're just cutting that first half in half, then we're going to cut the second half in half. We'll see that in the next slide, actually. And so the middle 50% is what we call the IQR. It's less sensitive to extreme values like the regular range, the simple basic range, deals with the maximum and the minimum. The IQR really just says what's in the middle, and let's get the 50% range from the first quartile middle and the third quartile middle. We'll take a look at what that looks like in the next slide. And then the third type of range, or way of looking at how spread out these values are for a variable, is the standard deviation. Now this one is a little bit more complex in terms of calculating it. We'll look at how you do that. You'll never really have to calculate the standard deviation. You'll just have to know how to interpret it, and that's what this class is all about. Not just some cases we are calculating, but in all cases, whether we calculate or not, we must know what that number means. Okay, so the standard deviation describes how much the data do or do not cluster around the mean. So the range, we deal with the max and the min. The interquartile range, we deal with the middle, right, the median, and then the standard deviation, we're dealing with the mean, right, the average, and it describes the difference between every item in that data set and the mean. So every value in that data set, it compares it actually, and sees how far apart it is from the mean, and we're going to take a look at that as well in future slides. So the more spread out the distribution, the larger these three measures of spread will be always. So if you have a range of 30 for one set of variables for age, and you have a range of 43 for another set of variables for age, then guess what? The 43 means that that set of variables, that data set with that age variable is more spread out. Okay? Alright, so we're going to look now at how to calculate percentages and quartiles and what these numbers, what these words mean. Okay? Percentile is essentially the value such that a percentage P of all values are less than it. So as you've taken a standardized test before, and so when you've heard the term or you saw in your results, I am at the 97th percentile, oh my gosh, guess what, that's awesome. That's actually super duper awesome, because if you see what this first line says, it says that all values such that the percentage P of all values are less than it. So if you're at the 97th percentile, you're higher than you made a higher score, right, than everybody at below that percentile, which is awesome. So you did very well on that exam, right? Quartile is just it tells us similar things, but typically we don't ever have like a 93rd quartile. Quartile means 4. There are 4 parts, right? When you cut a pizza into 4, you can take a quarter of it, right? That's just 1 part. And so in a quartile, you should expect to see 4 parts. Quartile, the first quartile is essentially the exact same thing as saying the 25th percentile. The second quartile is that midway point, the median, and so we know that the second quartile is the exact same thing as the 50th percentile, which is the exact same thing as the median. We just took that pizza, we cut it in half, or we took that Snicker bar, we cut it in half, and that is our median. Our median is whatever is the smack dab in the middle, 50th percentile. So you are at 50th percentile, so you're just at the halfway point. You did better than 50%, but 50% of the people did better than you. Okay? And then 75 percentile, so that's the other, at the other end of that Snicker bar. You cut it in half, and then you take that half, you cut it in half again, right? The half on the first side is that first quartile, or 25th percentile. The half on the other side that you cut in half is your 75th percentile, or your third quartile. Same thing, right? The quartiles, I just said that, I'm reading the second line now, divide the data into 4 groups, each with a quarter of all observations. A quarter of all observations, okay? Naturally, the first, second, and third quartiles, as I said, are the 25th, 50th, and 75th percentile. 0 percentile means it's the minimum. you did not do, everyone essentially did better than you. The maximum, you would call that the 100th percentile, because you did better than 100% of the people. You have a higher score than 100% of the people. That's all the people. Okay? Alright, so now let's look at how to calculate the standard deviation. So we've talked about range, we've talked about interquartile range, which deals with the median. Now we're going to talk about the standard deviation, which deals with the mean. Before we do, though, let's count how many observations. We're going to actually just kind of go through what we see here on the screen and figure out these answers before we get down to the bottom, where we see that really crazy looking equation that we're going to so conquer and get through so easily. So let's move. Alright, the number of observations, n, we remember that that's n, and we can count at the first column. We see that there are 14 observations, so we should have 14 for that answer. So again, this table is sort of like a frequency table, at least the first, or actually it's not like a frequency table, it's just a regular Excel type table, and you listed out all of your values. Let's say this is age, okay? So we have someone that's 59, someone that's 60, someone that's 61. We have 2 people that are 62. We have 3 people that are 63, 2 people that are 64, and so on, right? So based on what we just looked at in that second column, what would our mode be? If you said 63, then you are correct, because our mode is the number, the value that is seen most frequently in that data. Okay? So for this particular variable, let's call it age. Then what this means is that of the 14 people, the age that was most frequently seen in this data is 63. The median, how would we calculate that? We essentially take this thing and we cut it in half. Now we have our equation, right? We know that our equation is n plus 1. We already know what n is. So we add 1, that's 7. Excuse me, that's 15, and we divide by 2. That's 7.5. Okay? So if we count down, and even if we didn't know the equation, at least in this case, we can't do this in all cases, particularly if we have like 10,078 cases. We're not going to sit here and count. But at least in this case, we know that we can count down 7. 1, 2, 3, 4, 5, 6, 7. At 7, we have 63. At 8, because 7 is the halfway point, we know our n number of observations is 14. So if we cut that in half, we have 7 and we're at 63, the age 63, but we need to get to 7.5, right? So between 7 and 8, they're both 63, so the halfway point is still 63. And just to further drive this point, say 7 was 63, but 8 was 64. Then what would we have for our median? Well, we would, that 7.5 observation would be 63, between 63 and 64. So our median would therefore be 63.5, right? Okay, so now our mean, because this is what's most important for standard deviation calculation. Okay, so our mean, how do we get it? Well, it's already listed out all of the values. So essentially we would add up all of these values, divide by n, the total number of values that we have, which is 14, and we should get the number 63.4. And if you notice in the third column, I wrote down 63.4 all the way down because this sheet essentially is what I created so that I could help you guys see how that equation at the very bottom, how that's really working, okay? So so we know what xi is, that's all of our actual values. We know what x bar is, that's our our mean, our average. So we're going to just write that all the way across, all the way down, And so now let's move to the fourth column, step 2. We square it because that equation at the bottom right, we see that after we we subtract. So after we've gotten our number, our value, and our mean, we subtract the two. So 59 minus 63.4, the answer there you see is negative 4.4. We do that all the way down. As you can see, we finally get to the positives when we start with 64 minus 63.4, we get 0.6. 68 minus 63.4, we get 4.6. Okay? Then let's go back to that equation at the bottom right. It says that we square what we just got, what we just calculated. We need to square that. So we should not see any negative numbers after we square this thing because negative times negative is positive. So negative 4.4 times negative 4.4. That's what squared means. So negative 4.4 squared is 19, right? Let's go all the way down to the bottom. 4.6 times 4.6 should give you 21.6, or 4.6 squared is 21.6. Now, step 4 is essentially, if you remember what we said about that E sign, that sigma sign, all we're doing is adding up everything we just squared and calculated. And that number should sum up to 85.2. Okay? Now, the last thing we do, which we don't see here, is we divide by n minus 1. We already know n is 14, so n minus 1 is 13. Actually, I skipped through some things there. You can figure out how to calculate range, right? And first and third quartile. And now we're moving forward. We got the sum of squared deviations. N minus 1 is 13. And so once we get those two numbers, 85.2, I don't know where I came up with that number. 85.2 is that sum of squared deviations. We divide it by n minus 1, which is 13, and we should get we should get a number that I skipped there and moved straight to the standard deviation, but the number should be 2.6. Well, we see here now that we know how to calculate the standard deviation, it should be 6.7 distribution, which we take the square root of. Very scary, I'm sure. Okay. But all take the square root of it, and that number is most data actually that becomes our fall within this normal. Our answer for the standard deviation, most data that we calculate, it's normally distributed. So I challenge you to figure out how I calculated the range, how I calculated the first mathematicians have done studies after studies We're not mathematicians and we're not going to get into that, but we accept what they've done for centuries now, and we understand that data falls along this type of curve. That most people kind of hover around in the middle and have sort of similar um, values to the mean, whatever that mean is. Mean is always at zero, as I've noted here. And most people kind of hover around that. And then the further away from the mean you are, the less data you'll find out there. So there are a few people, right? Essentially, what this means, there are a lot of people that kind of uh, have the same sort of values as the mean, or close to the mean, and we don't have a lot of people that have that are so far away from the mean. Okay, and so the purpose of looking at this graph here, this picture, is to show you what the standard deviation means. At zero, again, that's the mean. And so one standard deviation away from the mean, to the left and to the right. To the left, it's about 34%. So at that -1 mark from zero, that's about 34%. And then the other half is the 34% from zero to +1. So that gives you a total of 68%. And if the values, I'm reading what you see there at the bottom, if the values of a variable are normally distributed, then what that means is that about 2/3 or 68% of the values or the responses fall within one standard deviation of the mean. Okay, so if the values of this variable are normally distributed, then 95% of the variable's responses fall within two standard deviations of the mean. And if it's normally distributed, then about 99.7% of the values fall within three standard deviations of the mean. So that's practically all the data, right, at minus 0.3%, fall within three standard deviations of the mean. And you'll see things outside of this, those data or those values or responses typically are outliers. Anything that's that far out away from the mean. Okay? Alright, so the rules for interpreting standard deviation. There are three empirical rules for interpreting standard deviation. If the values of a variable are approximately normally distributed, as we saw in the previous slide with the bell curve, that's what it's called, a bell curve, then the following rules hold. And we just mentioned this, but I wanted you to see another way in which you might see it in the future, where it's x bar, we know that means mean, x bar plus or minus s, which we know means standard deviation, x plus or minus 2 times the standard deviation, and then x plus or minus 3 times the standard deviation. So fortunately for us, many variables in real world data are approximately normally distributed. So for example, if the standard deviation, s, for the variable age, okay, is 15, and the mean, x bar, for that same variable is 45, then using the equations above, that x bar plus or minus s, plus or minus 2s, and plus or minus 3s, what we can do is calculate what that range would be for 68% of the data, for 95% of the data, for 99.7% of the data. So our mean at 45, and we subtract 15, which is our standard deviation. So the lower end of that standard deviation range would be 30. 45 plus 15 is 60. So 68% of our data fall within 30 years old and 60 years old. So 60% of our data gives us a range of about 30 years wide, right? 95% of our data falls between 15 years old and 75 years old. Okay, what we did is 45 minus 2 times 15. 2 times 15 is 30. So 45 minus 30, that should give us 15. 45 plus 30, that should give us 75. So 95% of our data falls within a 60-year range, 15 and 75, right? 75 minus 15, that would give us 60 years range. And then the 99.7% of our data fall between the years ages 0 and 90. So practically all of our survey respondents um, would fall between 0 years old and 90. Now, anything we get outside of that is probably an outlier, and or sometimes outliers can indicate that the data is um, something went wrong, right? Somebody inputted the information wrong because someone can't be negative 3 years old, and someone is possibly 110 years old, but we would want to check that and make sure that that's actually valid, and that we didn't accidentally type 115 instead of 15, right? So that's how we interpret standard deviation. All right, so actually I just talked about this very briefly, but outliers. An outlier is literally a value or an entire observation that lies well outside of the norm. Like I mentioned, the negative 3 years old person, something probably went wrong there. But the 93-year-old person maybe actually filled out the survey. Hey, who knows? But that person might I would say might possibly be an outlier, depending on if the highest the next highest age, if that was like 50, then we would say definitely a 93-year-old filling out the survey um, would probably be an outlier. Statisticians disagree on an exact definition of an outlier. You might define it as an outlier. Excuse me, an outlier as in any value more than 3 standard deviations from the mean, as I mentioned earlier. That is just a rule of thumb, but depending on the researcher and the type of research, they may decide differently. And I think outliers are very more obvious to detect visually. So these graphs and pictorials help you to see outliers a little better than just looking at the numbers sometimes. And so take a look at the other two bullet points here. Okay. Ways to sum up a variable. So we talked about the mode, the median, the mean, and we talked about various ways of measuring spread. And these, depending on how large that thumbs up is, tells you how useful these measures help you to measure or to describe a particular type of variable. If the variable is dummy or nominal, interval or ordinal, and whether they are affected by extreme values. A mode obviously wouldn't be affected by an extreme value, because even if the value is 93 years old, if there aren't more than one 93 years old, why would that matter, right, for the mode? And so just take a look at this chart and, feel free to reference it moving forward. Alright, so we have finished lecture 2. Woo, aren't we excited to move on to practice exercise 2 as well as homework 2. The Excel functions you're going to use are as follows. And please take note of the standard deviation, because there are a couple of them. Oh, actually, there are a couple of them for the percentile and quartile functions as well, but use the one that says exclusive. And use the one that says standard deviation for a sample, because right now we're only dealing with samples, right? Alright, thanks. Take a look at this, maybe just for the homework assignments, be it, for lecture 2, and most definitely as we move forward in lecture 3, 4, and 5, these bullet points are actually pretty useful.